What's up, everyone? This is a video lesson for section 6.8. In this video, we're going to be looking at parent graphs for secant, cosecant, tangent, and cotangent functions. So let's start with the tangent function. To graph this, we're simply going to make a table of values. We're going to plug some values in for x in degree form, okay? So tangent of 0 degrees is 0, pass through the origin. Tangent of 30 degrees is approximately 0.577. You can check that on your calculator. Tangent of 60 degrees is approximately 1.732. And then tangent of 90 degrees is going to be undefined. That's because at 90 degrees on the unit circle, you'd be at the point 0, 1. Tangent there would have a ratio of 1 over 0, which is undefined. And graphically, what that means, you'd have an asymptote at 90 degrees. The curve is undefined right there. At 120 degrees, tangent is equivalent to negative 1.732. At 150 degrees, tangent is negative 0.577. And at 180 degrees, tangent is back to 0. Okay, and I can reason out further points just by making some observations here. Consider all students take calculus, okay? So in the first quadrant, notice that the 3 points that I plotted at angle measures of 0, 30, and 60 degrees, see how those points, they all are above the x-axis, meaning they have positive y values, right? That's because all functions are positive in the first quadrant, all right? Then after the asymptote at 90 degrees, the next 3 points that I plotted, those correspond to second quadrant points. And see how they are below the x-axis, okay? That's because in the second quadrant, tangent is negative, right? When I get into the third quadrant, tangent is going to turn back to being positive. So that means at 210 degrees, I should be back to positive 0.577. At 240 degrees, positive 1.732. And then I'll get an asymptote again at 270 degrees, okay? And then when I move past that asymptote into the fourth quadrant, tangent is negative once again there. So at 300 degrees, I should be at negative 1.732 again. And at 330 degrees, I should be at negative 0.577. And then at 360 degrees, I'm back to 0, okay? And then we can even kind of repeat these patterns going into the negatives as well. So at negative 30 degrees, you should be at negative 0.577. And at negative 60, we should be at negative 1.732. And then at negative 90, we'll have an asymptote once again, okay? So we have a lot of points helping us to define the curves here, and there's multiple curves that will take on this behavior. Okay, and what I want you to notice is that each piece of the curve from asymptote to asymptote, they're always increasing as you move from left to right. Okay, now let's trace this out even better using technology. All right, so I'm going to pull up the tangent curve here. So as I move around the circle, you're starting to see the curve take shape here. And I can go in the negative direction, and there we have it. Okay, you kind of zoom out a little bit, and you're seeing a good portion of the tangent function here. All right, now, let's identify period, domain, range for this. The period is going to be 180 degrees. Okay. That's because the curves repeat themselves in between each set of asymptotes, right? And there's 180 degrees between the asymptotes, all right? Now the domain is going to be based on where the asymptotes take place. Our first one was at 90 degrees, and then the next one was 180 degrees later at 270. So domain, we're going to say, is anything but 90 degrees plus 180 degrees times n, where n is just representing an integer. So basically we're saying there is you're going to get asymptotes at 90 degrees plus any multiple of 180 degrees. Okay. And then notice your range, you can tell very easily from the graph, it's all real numbers. Okay. All right, now cotangent function, graph's going to take on a similar appearance, okay? Cotangent is undefined at 0 degrees. So we have an asymptote right off the bat. Cotangent of 30 is 1.732. Cotangent of 60 is 0.577. Cotangent of 90 is 0. Cotangent of 120 is negative 0.577. Cotangent of 150 is negative 1.732. Cotangent of 180 is going to be undefined again, so another asymptote. Okay, so those points all together make one full cycle, and they're spanning from quadrants 1 to quadrants 2. Okay, so again, consider all students take calculus. Notice that in quadrant 1, from 0 to 90, the points are above the x-axis. In quadrant 2, they are below the x-axis because the cotangent function should be negative in quadrant 2. All right. Now, when we get back into the third quadrant, so that's from 180 to 270, we should be positive once again. Okay, so the points from quadrant 1, they're going to have the same y values in quadrant 3 as well. Okay, so at 210 degrees, we're at 1.732. At 240, we're at 0.577. At 270, we're back to 0. And then we move into the fourth quadrant where we should be negative. At 300, we're at negative 0.577. At 330, we're at negative 1.732. And then 360, another asymptote. Okay, and then we can carry these patterns over into the negatives as well. All right, so obviously a very similar behavior to the tangent function. It's just your asymptotes have been shifted, and notice between each asymptote the curves are now decreasing. Okay, now a little bit more on why this curve's decreasing as compared to the tangent increasing. So the cotangent function is defined as x values over y values, right? So you got to think that as you move around the curve or around the circle, as you increase the value of your angle, your x values are getting smaller and your y values are getting bigger, okay? So if x is smaller in your numerator and y is bigger in your denominator, then the value of the overall fraction is going to decrease. For the tangent function, it would be the opposite, okay? Tangent function's y over x, so your numerator would be increasing, your denominator would be decreasing, and the function would appear to be increasing overall, okay? Period for this is going to be 180 degrees. Okay. Domains based on the asymptotes, they occur at 0 degrees and then not again until 180. So I can just say x is 180 n. Okay. And then my range, all real numbers.